Good afternoon, children. So, as you all know, yesterday we talked about Kirchhoff's laws, and then I explained you Kirchhoff's law using a example from your NCERT book. I think you might have seen in the NCERT book, and as I told you that you can go through an example 3.7. So, you might have gone through that example also. Now we'll repeat the same concepts again. I'll be solving one question and one question I'll be giving you for doing so that you become familiar with how it has to be solved. Once you are able to solve these type of problems, then you can go in for other problems from your refresher books. Now see the questions which come in which you have to use Kirchhoff law. So identification is in most of these questions you will have more than two sources of EMF. So as soon as you see in your figure that there are two sources of EMF or more than that, that means you are going to use Kirchhoff's laws and not directly the Ohm's law. See, this is again an extension of Ohm's law itself, but it is in some other simpler form to solve problems with multiple source of EMF. So the question come in three forms. One is the question may come in language form only. Like I'll just speak out the language for this question. Two sources of EMF E1 and E2 are connected in parallel. Two sources of EMF E1 is equal to 4 volt, E2 is equal to 2 volt with internal resistances 2 ohm each is connected with an external resistance in parallel with 8 ohm. Find out the current through each of the sources of EMF. This is one way of asking the question. So what you are going to do in that case, you have to draw the circuit diagram also yourself. But in general, most of the time when Kirchhoff law question is asked, diagram is most of the time we expect it is given, but it can be there that diagram is not given, it is given in language form just like I stated. So then you will connect two sources E1 and E2 with 4 volt and 2 volt in parallel with internal resistance 2 ohm each. Then connected in parallel an external resistance 8 ohm. Find out the current through each of the sources of EMF. So you have drawn, or if it is already given like I am giving you in drawing itself. Third step is you have to check whether the direction of currents are given or not. So the third step is to draw the direction of current. How? Just see, I'll explain one of them. See, these are the two sources of EMF and this is also a resistance. This is again a resistance. This is again a resistance. See, this is the positive terminal of the battery. I can take current I1 like this. Certainly it is going to flow like this, come to this point. Now it has got two paths to move around. One is this, one is this. Certainly only one direction you have to make, you cannot make both the directions. Now from here, say this is positive terminal. So I can do one thing, I will take current from here also, say take it as I2. Now these both current have come here, they will pass through this. So this will be current I1 plus I2. It will move through this branch, move up to here, and I1 will go like this and I2 will come like this and the circuit will be completed. See, as far as the current direction is concerned, you can draw it like that. Even if you don't do it like this, you can take any arbitrary direction. You can take this direction also here. That doesn't matter. Later on, what will you do? I told you that if the direction of current is going to come out as I2 only, then you will get a positive answer. And if I take an arrow like this, then in that case I will get a negative. So that is the only difference. Both are correct. So both methods can be used. Next step is, we have drawn the arrows now. We'll now consider a closed circuit. We'll consider a closed circuit. How many closed circuits are here? One is A, B, E, F, A. Another is B, C, D, E, B. The third is A, B, C, D, E, F. We usually require only two equations for two unknowns. So therefore, two circuits are enough for me. See, here I would have taken I3 also. I would have taken I3 also, but from the junction rule, I3 will come out to be equal to I1 plus I2, as we did yesterday. Now we'll try to write the equation. Yesterday I told you that one of the directions of the current is to be taken as positive, another as negative, and on all the circuits the same convention is to be taken. Same convention. That means if you are taking anti-clockwise positive, keep on taking anti-clockwise positive. So anti-clockwise, positive, clockwise, negative. That is up to your choice. You can take the other way around also. That is imitated. So in the way you write in examination also, enclosed loop, you can use the word mesh also. A, B, E, F, A. Start from anywhere from the circuit. We'll start from here. I1 is anti-clockwise. 2 into I1. It will be positive. R multiplied by current. Come here, no resistance, come to here. The resistance is 4 ohm and the current flowing through is I1 plus I2, and it is again anti-clockwise. So plus I1 plus I2 into 4. No resistance is equals to, check the source of EMF. E1 is there. It is again moving from positive terminal to negative terminal like this. It is again anti-clockwise. 12. This is your first equation. So this is going to give me 2I1 plus 4I1 plus 4I2 is equal to 12. This is going to give me 6I1 plus 4I2 is equals to 12. This is my equation number 1. Now I can take closed mesh in closed loop B, C, D, E, B. Now I'll forget about the first circuit. We'll treat as if it is not there. Now come. See, if I move it like this is clockwise direction. Clockwise is negative. Minus I1 plus I2 into 4. This is clockwise. What about this? I2 flowing through I1, this 1 ohm resistance, it is again clockwise. Minus 1 into I2. There is no other resistance. Is equals to, move from positive, again it is clockwise, see, moving from positive terminal to negative terminal, minus 6. This is going to give me minus 4I1, minus 4I2, minus I2 is equals to minus 6. Minus 4I1 minus, so this is 4I1. See, negative is there in each and every term. So we can cancel out all these. So I'll get 4I1 plus 5I2. See, minus 4 and minus 1 will give me 5I2 is equal to 6. This is my equation number 2. So now you have got equation 1 and equation 2. Solve these two equations and you'll get an answer for I1, I2, and in the third branch also, branch B also, as I1 plus I2. I think you can easily solve these two equations. You can use any of the methods to be used for solving these two equations. The answer for this will come out to, for I1 it will come out to, must come out to be 18 upon 7, and for I2 it must come out to be minus 6.7. Try to do the question and see that you get the answer. Now this question I am giving you as a homework, and I'll tell you the answer on Monday. In the meantime, do the question and post the answer on my WhatsApp group. Let me see how many students do this question and find out the answer. First you will do this and then do this. See, directions you can make, I can give also, but you can make like this. See, you can take it as I1, I2. This is going to move towards here up to this junction. This will also come to here. So here the current will be I1 plus I2, which can also be taken as equal to I3. So find current flowing through the two cells. I think you can try doing it. And once you are able to do this, then you can do some extra problems so that this topic is prepared for you, because from this topic numerical question only will appear. You shall be able to find out the resistance as well as the potential difference across any of the resistors or any of the two terminals. Thank you.